telescopes on Earth use segmented primary mirrors, Webb is the first telescope in space to use this design. The 21-foot or 6.5-meter gold-covered mirror was far too big to fit inside of a rocket fairing, however, and so it had to be folded up for launch. After Webb successfully made it into space, the 18 hexagonal beryllium mirror segments that make up the primary mirror then unfolded. But for the telescope to work properly, all of these segments have to be aligned with extraordinary precision. Aligning each segment into one smooth reflecting surface was one of the most important tasks the Webb control team had to tackle since the telescope launched. According to NASA's recent news conference, however, the primary mirror is now fully aligned within a fraction of the width of a human hair and performing even better than expected. Although many other alignment steps and tests need completing before Webb ultimately delivers the new view of the cosmos, this fully focused image is the highest resolution infrared image ever taken from space, providing us with a tiny glimpse of how powerful Webb is. The star at the center is called 2MASS J17554042 plus 6551277, and although it is the brightest thing in the image, emanating streams of light across the universe, it is nothing particularly special. It is just a generic, anonymous star with the right level of brightness used to make sure that the mirror alignment is precise enough, a test star if you like. It's what is surrounding the star that is interesting, the spray of tiny dots scattered across the background, because these specks are distant galaxies billions of light years away that have never been observed before. These mysterious, distant galaxies make this crystal clear image a so-called deep field image, which is an image that has captured the most distant objects in the universe. The Hubble Space Telescope requires days, sometimes weeks, to obtain some of its most famous deep fields, such as this one, whereas Webb will be able to accomplish the same results in just hours. The James Webb Space Telescope is designed to be 100 times more sensitive than Hubble, but the two observatories do not image in the same wavelengths. Hubble is an expert in mainly visible and ultraviolet radiation, while Webb operates in the realms of infrared. It's important to remember, however, that this is only a test image. The glorious vistas, such as those captured by Hubble over the last 30 years or so, will come later, once the observatory is fully operational. But even though it is a test, it does represent the beginning of what we will soon be observing. The James Webb Space Telescope will allow us to peer back in time and capture the first galaxies that formed only a few 100 million years after the Big Bang, potentially transforming our understanding of the cosmos. And I, for one, cannot wait.